Test probably went. Test, actually, I think test might be like Friday? No, it might be the week after this next week. I can't remember. It's not very close. It's not that close. Okay, how many dimensions does a line have?
2.
1. One dimension. So a dimension is like left and right. That's one dimension. How many dimensions does a polygon have? 2. Let's say 2D. Okay, left and right, that's one dimension. Up and down, that's the second dimension. You can get anywhere on this rectangle by going left and right, up and down. How many dimensions does a prism have? 3. Left and right, up and down, front to back. We live in 3D, right? We live in 3 dimensions. Some people say time is a dimension because you go forward.
Do you believe that, Mr.
Who knows?
We can acknowledge that.
But anyway, spatially we live in 3 dimensions. So that's kind of relevant to what we're talking about today. So I just want to review that a little bit. Oh, well, actually, before we move on, how do we measure a line? How might we measure this line?
Subtract the endpoints.
Huh?
Subtract the beginning of endpoints.
No, just like with a ruler or something like. Maybe it's like 40 inches.
Line it up.
Maybe it's like 20 inches.
Line up with a ruler?
Yeah, we'd use like a ruler. How do we measure the size of a rectangle though?
Multiply the base times the height.
Right. We can use a ruler for the base and the height, but then when we multiply those together to figure out how many little squares fit inside here,
So
that's
square.
yeah, areas. Yeah, you have to multiply the 2 dimensions. And then for a volume, how much fits inside this rectangular prism, you have to multiply the 3
Width
dimensions.
times length.
Length times width times height.
Height.
Anyways, okay. Back to similar stuff. So we haven't really talked about it that much, but just like rectangles can be similar, you can also have similar prisms, which are the same shape but different sizes. They have like all the same angles, all the sides are in the same ratio, proportional. So there is a little bit of 3D stuff on today's. Doesn't really matter that much. Okay, let's say that this is 9 and 6 and 12, 12 and 8 and 15 and 10. Let's say these are right triangles. So are these, how would I check to see if these triangles are similar?
See if they reduce to the same, which they do with.
Right, does 9 over 6 equal 12 over 8 equal 15 over 10?
3 over 2.
Yeah, they all reduce to 3 over 2. You guys remember what the book called this right here? It's called it the Similarity Ratio. It basically tells you the ratio of any sides on similar shapes. Similarity ratio. But it doesn't just do that. It also, if I draw another line in here, like, oh, here's a question, you guys probably forgot this one. What's a line called that goes from the vertex to the opposite, middle of the opposite side? Median. Somebody did remember. Okay, if I draw a median in for both of these two guys, guess what the ratio of the medians is? 3 to 2. It's the same. It doesn't matter what length you're talking about. Any corresponding side is going to have the same ratio. Any corresponding length is going to have the same ratio. How many dimensions are all these lengths that we're talking about?
2.
1. We're talking about a straight line, right? Straight lines. So all these straight lines are in the same ratio, 3 to 2. What do you think would be the ratio of the perimeters?
3 to 2.
Why do you think it's 3 to 2, Will?
Well, they all have their 8 sides to the corresponding sides are always 32, so if you add all of them up, they should also be 32.
Okay, we can actually check and see if that works. So if I add all these together, 12 plus 15 plus 9, that's 36, I believe, yeah. And then 6 plus 10 plus 8 is 24. If we do, so this is the ratio of the perimeters. What's that reduced to? Divide by 12, divide by 12. Yeah, the ratio of the perimeters is also 3 to 2. The exact same. Why is it the same? A perimeter, if you think about it, if I take some scissors and cut up these corners and then stretch out the sides, what does it make?
A line.
A line. The perimeters are just lines.
How does that work with the area though?
So all these one-dimensional things, all these straight lines, are in the same ratio, 3 to 2.
I'm guessing
Okay,
the areas.
how about
also
area?
32.
So, how about area? Let's go ahead and find the area and then we'll see if you guys can figure out how it's. Do you guys remember how to find the area of this
12
rectangle?
times 9 divided by
12 times 9 divided by 2 is the area of this triangle. What is that? 54, I believe. Let me double check, yeah. Okay, and then what's this one?
8 times 6 divided by 2.
8 times 6 divided by 2.
24.
Okay, so we got a ratio of areas is 54 to 24. What do those both divide by? 6. Divide by 6, it's 9 to 4.
Oh, so they're twice that?
Okay, how are these two related? That's the question.
That's
3
twice.
squared takes 9.
They're squared.
Okay,
Right.
squared. Yeah, 3 squared is 9. 2 squared is 4, right? So the ratio of the areas, two-dimensional, is the ratio of the sides squared. Does that make sense? The ratio of the sides, 3 to 2, all the sides,
Is one dimensional.
that's one-dimensional. When you square it, you get the ratio of the areas, yeah.
To find the volume, if it's a three-dimensional shape, would you cube it?
Yes. Okay, I was about to get to that. So, areas, here's basically why it works. When we find areas, since it's two-dimensional, you have to do like 12 times 9. You're kind of multiplying that ratio by itself twice. That's why it's squared. Anyway, yeah, and then Tristan jumped to the punchline here. So, if you do volumes, because it's three-dimensional, that would be the ratio of the sides cubed. So, do you guys know what 3 cubed is? 27. And 2 cubed is, whoops,
2 cubed is 8.
yucky. Okay, so this would be the ratio of the volumes if you had a three-dimensional shape. Okay, so it's one-dimensional, all the lengths. It's the basic similarity ratio. We've been using this a lot. Ratio of areas, 9 to 4. And the ratio of volumes is cubed, 27 to 8. So one-dimensional, two-dimensional areas, three-dimensional volumes. So here's what's gonna happen today. They're gonna give you like maybe the area of one of the triangles. Let's say we knew the big triangle was 54. And then they'll say, so find the area of the small triangle. So the ratio of the areas is going to equal the ratio of the actual areas of the triangles. And then we have to cross multiply. Does that make sense? Well, we'll look at it later. Let's say that they give us the ratio of the areas is like 25 to 16. Ratio of areas. Then what's the ratio of the sides going to be? The ratio of any two sides going to be?
Square root.
Square root. Because remember, you have to square the sides. Right, if these were the sides, 5 and 4, you square these to turn it into the ratio of the areas, right? So how do we go backwards to turn it back into the sides? What's the opposite of squaring?
Square root.
Square rooting. So if we ever have to go backwards, get down, go to the lower level, the opposite is square rooting. Okay, anyway, let's get started. Number 1. What page are we on? 452. All right, summarize the theorems presented in the section by stating each ratio. Theorems are just all the stuff that we were just talking about. They don't have any names or anything. Number 1A, any length related to triangle ABC to the corresponding length in triangle DEF. Okay, do you guys see those triangles on the right over there? What is the similarity ratio between those two triangles?
X over Y.
X over Y. Do you guys see how I got that? Those two line segments on the bottom are X and Y. So the basic ratio between the triangles is X to Y. Question A is basically asking what's any length in the first triangle compared to any length in the second triangle. What's that ratio going to be? X over Y. Any length, all lengths in those two triangles are going to have the same ratio, X to Y. B, the perimeter of triangle ABC to the perimeter of triangle DEF. So what's the ratio of the perimeters between those two triangles going to be? X to Y. Remember, perimeters were also one-dimensional measurements. They're basically a length, just like any other length. C, what's the ratio of the area of the first triangle to the area of the second triangle?
X squared to Y squared.
X squared to Y squared. When we're going up to areas, we're going into two dimensions. That's when you have to square the ratio. And maybe you guys see where this is going without even reading D. Hopefully some of you do. They're saying if those triangles were the faces of a three-dimensional solid, then what would be the ratio of the volumes? X cubed to Y cubed. If one makes a lot of sense, then you're on pace to do well. If not, you stop some time and pick it up. It's okay. Number 3. I kind of don't know why they put 2 through 4 in here. It's kind of a review of the other stuff we've already done. We just have to solve for Y. So somebody help me set that up for Y. All right, Trevor.
4 over y and 5 over 15.
4 over Y equals 5 over 15. These are not trick questions. So just do the normal stuff. 5 times Y equals 4 times 15. Whoops. 5 times Y. 4 times 15 is 60. You guys remember your times tables? How many times is 5 going to 60? 12. Okay, number 5. All right, number 5 says, state each smaller to larger ratio for each pair of similar figures. The order matters. They said smaller to larger, so we got to go smaller to larger. On number 5, this is not the answer, but what is the similarity ratio for those two shapes?
5 to 3. 3 to 5.
3 to 5. Smaller to larger. Okay. 3 to 5. So the question on A is, what's the ratio of the perimeters going to be? 3 to 5. Correct.
Why'd you say that wasn't the answer?
Because I was just talking about the ratio of the sides, not the ratio of the perimeters. Coincidentally, yes. Okay, B, what's the ratio of the areas of those two shapes going to be?
3 squared to
3 squared to 5 squared, which we're not going to leave it like that.
5 reduces
Well, it doesn't reduce, it just
9 over 20.
9 over 25.
Do you have to do that on 6?
6
Pretty
is
much.
similar, yes. Pretty much same idea.
But like,
Number 7. Okay, 7 is a cube with edges 6 and another cube with edges 9. Okay, if the two cubes have edges of 6 and 9, what's the similarity ratio between those two cubes?
6 and 9.
What is 6 to 9 reduced to?
2/3.
2 to 3, right? Okay, so that's the basic ratio for number 7, 2 to 3. That's not the answer yet. 7a says, what's the ratio of the surface areas?
Square them, so 4
Right.
to 9.
Areas, remember, all areas are two-dimensional, so that's where we have to square this thing for the area. So 2 squared is 4, and 3 squared is 9. Okay, B says the ratio of the volumes of those two cubes. How do we find volume?
Cube.
We
So,
cube those two
7.
things. You guys know what 2 cubed is?
8.
8, and 3 cubed.
27.
27. Okay, number 9. Okay, oh, look at that, those messy little triangles over there.
These aren't really true questions, are they?
I don't think they'll be too bad. Does kind of as a side note here, do you guys remember what CD line, what kind of line CD was?
Median.
No. Altitude, yeah. It basically tells you the height. It shows the height of the triangle, so that's an altitude. Do you guys know what kind of line FB is? FB, angle bisector, because it's splitting angle B. And AE, we kind of already asked that one, but AE is called a median because it goes to the middle of that CB. Anyway, that's beside the point. Number 9. MQ is what we're looking for. They give us CD is 9 and OP is 3. Those are the altitude, so that those are matching parts, so that they're going to be in the same ratio. What does 9 to 3 reduce to, by the way? 3 over 1. So that is our similarity ratio, 3 to 1. Now let's keep reading the question. It says AE is 12, and we're looking for MQ. Is AE on the big triangle or the small triangle? It's on the big triangle. So I need to put that 12 across from the big number. Okay, big triangle, small triangle, small triangle. Yeah, so 3x equals 12 times equals 12. So x is 4. Okay, number 11, find the perimeter. So on 11 it says perimeter, we're looking for perimeters. How does the perimeter relate to the original ratio?
Squared.
It's the same, not squared, that's area. Perimeter is a one-dimensional measurement, so we're going to keep it the same. So the two sides they give us, MO and AC, it's like the left side of both of those triangles, are 9 to 18. Oops, I was looking at 10, my bad.
I know, we can do that.
11, FB is 10, RN is 7, so if the ratio of those two sides are 10, two lines are 10 to 7, the ratio of all the sides
That's just.
is 10 to 7. Okay, and then it says the perimeter of triangle ABC, nope, I'm on the wrong one again. The perimeter of triangle MNO is 28. MNO is the small triangle. So where should I put the 28 at? Bottom. Because I put my 7 down at the smaller triangle side down here. So the smaller triangle perimeter should go down there. If you put it on the wrong side, you're going to get the wrong answer. Small should match small, big should match big. They should just go line up. Okay, then cross multiply 7 times x equals 280. You guys might be able to do this without a calculator. What's 280 divided by 7? 40. Okay, 13. Find the area. Okay, we're on an area problem. So what does that mean we have to do with the similarity ratio? Square it. So what is the ratio? Looks like BC is 9, NO is 6. Those are matching parts, matching the sides of the triangle. Let's go ahead and, so the similarity ratio is 9 to 6. What's that? Let's go ahead and reduce that. What's 9 to 6 reduced to? 3 to 2. Okay, that's the similarity ratio. How do I turn it into a ratio of areas? Square it. So 3 squared is, well, let's do this, 9, and 2 squared is 4. So the ratio of the areas is supposed to be 9 to 4. Okay, what's the next thing they tell us on 13? Triangle MNO, the little triangle, equals 20 yards squared. The area is 20 square yards. Where should I put the 20? On the bottom. Because triangle MNO is the little triangle, so this area should go across from the little side. The big triangle goes across from the 9x. Cross multiply 4x equals 180. 180 divided by 4, that's kind of a tricky one. 45. Oh, I haven't been labeling it, have I? Well, I forget myself. It's 45 yards square. Is that what you're gonna say? I'm quite generous with myself. Number 15. Find the area of a 20 centimeter long rectangle if a similar 8 centimeter long rectangle has an area of 48. So they're telling us the lengths of the rectangles are 20 and 8. So that's the similarity ratio. You guys know what 20 and 8 reduces to? Divide by 4, divide by 4.
5 over 2.
5 over 2. Okay, that's the ratio of the sides. How do I find the ratio of the areas? Square it. So this becomes what?
25 over 4.
25 over 4. So I want to point something out really quick. Just a little small note here. The original triangle, the length was 2.5 times, the big triangle is 2.5 times longer than the short triangle. But the area of the bigger triangle is over 6 times bigger than the small triangle. So length is 2.5 times bigger, the area is over 6 times bigger. So if you change those lengths at all, the areas start getting bigger faster. Okay, what was I doing? It tells us that the area, which area are they giving us? The rectangle with the 8 centimeter length has an area of 48. So in other words, the one on the bottom has an area of 48. So 48 should go on the bottom as the smaller rectangle. So we're looking for the bigger rectangle again. 4x equals something quite large. 1200 divided by 4. 300. Okay, Mrs. Brown plans to enlarge her 5 feet by 7 feet rectangle garden. I said that last time. Vegetable garden. Okay. The only time you'll ever see a 5 feet by 7 feet, they put a little X, like a time symbol there, is when they're talking about a rectangle. Okay? 5 by 7, this is notation used for rectangles, usually by like carpenter, maybe an architect or something. This is talking about rectangles. So her garden is 5 feet by 7 feet. I'll draw a little picture. 5 feet, 7 feet. That's a beautiful rectangle. What are the dimensions of a similarly shaped garden that has 9 times the area? So we got a much bigger garden. It's 9 times the area. Okay, if this area is 9 times this area, what's the ratio of these two areas?
1 to 9.
Yeah, or 9 to 1, right? This is 9 times bigger than that one. If this is the ratio of the areas, how do I go backwards and find the ratio of the sides? Square root. Carson, sit up.
So 3 for 9.
So the ratio of the sides should be 3 to 1. Can somebody turn that into plain English for me? If the ratio of the sides is 3 to 1, what does that mean?
1 to 3.
Just
How should these sides compare to those sides?
9 and it's 3 by 3. It's
7 to 5.
It's 3 times bigger. Yeah.
So that's it.
Okay, 3 times bigger. So that's what 3 to 1 means. It's 3 times bigger. That 9 to 1 meant the area was 9 times bigger. So if these sides are 5 and 7, they're asking what would the dimensions of these, the big rectangle, be? 3 times bigger.
Times that.
Yes. 15 feet by 21 feet. 15 feet by 21 feet.
Do we need to label them all?
No, I forgot to label quite a few actually. They only started labeling them when they got to number 9 because, yeah, the other ones weren't in inches and feet and all that stuff. Yeah. Number 19. Okay, is the directions say find the smaller to larger perimeter ratio for each pair of figures. How do we find the perimeter ratio? The perimeter ratio is the same as the similarity ratio. Same as the ratio of the sides. So it says the areas of the triangles are 16 to 4. Okay, if this is the ratio of the areas, how do we go backwards to find the ratio of the lengths of the sides? Square root. So what's the square root of these guys? 4 over 2, which reduces to 2 over 1. Okay, I just remembered the direction said smaller 1 to bigger 1. So we actually need to say 1 to 2 instead of 2 to 1. Okay, 21. Are circles always similar shapes?
Yeah.
Yeah, all circles are similar in shape, all spheres are similar in shape, all cubes and squares are similar shapes. Yeah, anyway, 21. Spheres have a circumference of 5 pi and 8 pi, two different spheres. 5 pi and 8 pi. Okay. Is a circumference, would a circumference be a length or an area or a volume? Circumference.
Oh.
Circumference is a length. It's like cutting the circle, rolling it out, and then measuring how long it is. It's like a length. It's like a perimeter, right? It's a perimeter for a circle. So this is a one-dimensional ratio. This is your similarity ratio. What is 5 pi over 8 pi? What does that simplify to? 5 to 8. So the ratio of any lengths is 5 to 8. Now let's look at the question. 21a says, what's the ratio of the radii of those spheres? 5 to 8. Radii are types of lengths. Radii is just a radius is just a line segment. So it's also going to be 5 to 8. B. Surface areas. What do we do to find areas? Square that guy. What's 5 squared? What's 8 squared?
Could you, do you want us to reduce it?
It doesn't reduce. If the original fraction doesn't reduce, when you square or cube it, it's still not going to reduce. Okay, yeah, cube this. Well, they asked for volumes on C, so we have to cube these two. 5 cubed is 125. What's 8 cubed? 512. Okay, before you guys get going, just warn you a little bit. 20 and 22 will have square roots in your ratios. So don't panic. Just like if you have an answer that's like square root of 5 to 2, which, I mean, that's okay. Just leave it like that. They got square roots in the ratios.